Is a heat exchanger? A heat exchanger is a device that transfers thermal energy between fluids at different temperatures without them mixing. It efficiently facilitates heating or cooling processes in various industrial applications, like these examples given below. Shell and tube heat exchanger and plate heat exchanger are mostly used in industries for heat exchanging. Now, let's delve into the different types of heat exchangers. We'll explore each type thoroughly in the upcoming parts of the video. Stay tuned for that. Shell and tube heat exchanger. A shell and tube heat exchanger is a type of heat exchanger that consists of a shell outer vessel and tubes inner vessels through which fluids flow, facilitating efficient heat transfer. The fluid flowing through the tubes is known as the tube side, while the fluid outside the tubes is the shell side. Tube side and shell side can have different flow arrangements, including parallel flow, counterflow, and crossflow. Shell and tube heat exchangers are well suited for high pressure and high temperature applications due to their robust design and efficient heat transfer capabilities. Shell and tube heat exchangers find widespread application in petrochemical, chemical, and power generation industries, as well as in process heating systems. Plate heat exchanger. A plate heat exchanger comprises thin, corrugated metal plates with fluid passages between them, designed for efficient heat transfer. The corrugations in the plates serve to increase the surface area and promote turbulence within the fluid channels, optimizing heat transfer efficiency. In plate heat, exchanger fluids flow through alternating channels formed by the plates, thus creating turbulent flow. The corrugated design not only promotes turbulence, but also helps to maintain structural integrity, allowing for higher pressure differentials between the fluids. Plate heat exchanger have compact design with high heat transfer efficiency. The compact design of plate heat exchangers makes them space efficient and well suited for applications where minimizing footprint is crucial. Plate heat exchanger are widely used in HVAC, refrigeration, dairy pasteurization, and food processing industries. Plate fin heat exchanger. A plate fin heat exchanger is similar to plate heat exchangers. A plate fin heat exchanger is a type of heat exchanger that utilizes stacked plates with thin surfaces to facilitate the transfer of heat between two fluids. These fluids can be gases or liquids, and the heat transfer occurs through conduction between the plates and fins. Plate fin heat exchangers operate based on the principles of conduction and forced convection. As fluids flow through the channels, heat is transferred from one fluid to the other through the plates and fins. Plate fin heat exchanger are suitable for applications with high temperature and pressure differentials. Plate fin heat exchanger are mostly used in aircraft engines, cryogenic systems, and automotive. Spiral heat exchanger. A spiral heat exchanger is a type of heat exchanger characterized by its spiral-shaped flow channels. It comprises two concentric spiral coils, allowing two fluids to flow in counter-current or co-current paths, facilitating efficient heat transfer between them. As the hot and cold fluids pass through the channels, heat is exchanged through the walls of the spiral coils. The counter-current flow arrangement maximizes the temperature gradient between the two fluids, optimizing heat transfer efficiency. Spiral heat exchanger provides a compact design with a high heat transfer surface area. Spiral heat exchanger are suitable for high pressure and high temperature applications. Spiral heat exchanger used in chemical processing, wastewater treatment, and beverage industry. Thin tube heat exchanger. A thin tube heat exchanger is a device designed to facilitate heat transfer between two fluids, typically air and a liquid, by utilizing extended surfaces called fins. These fins significantly increase the surface area available for heat transfer, thereby enhancing the overall efficiency of the heat exchange process. The extended surface area created by fins improves heat transfer by increasing the contact area between the fluid and the tube surface. In fin tube heat exchanger, extended surface area and turbulence created by fins lead to higher heat transfer rates. Fin tube heat exchanger is used in air conditioning, aerospace, and refrigeration systems. Adiabatic wheel heat exchanger. An adiabatic wheel heat exchanger is designed for heat and moisture recovery in air handling systems. Adiabatic wheel heat exchanger consists of a rotating wheel with hygroscopic material. As the air passes through the wheel, transferring heat and moisture to the wheel's material. The material then releases the stored heat and moisture to the outgoing air. Adiabatic wheel heat exchanger are ideal for improving indoor air quality. Adiabatic wheel heat exchangers are used in buildings, hospitals, and data centers for energy-efficient ventilation. Double pipe heat exchanger. A double pipe heat exchanger, also known as a tubular heat exchanger, consists of two concentric pipes through which fluids flow in opposite directions. The inner pipe, known as the inner tube, while the outer pipe, called the jacket. Heat is transferred from one fluid to the other through the wall of the inner pipe. In double pipe heat exchanger, heat is transferred from one fluid to another through conduction. As the fluids flow through their respective paths, heat is exchanged between them due to the temperature difference. Double pipe heat exchangers have a simple and compact design. Double pipe heat exchangers can achieve high levels of thermal efficiency, especially in counterflow configurations. Double pipe heat exchangers are mostly found in laboratory equipment, power generation, and oil and gas industry. Air-to-air heat exchanger. An air-to-air heat exchanger, also known as a heat recovery ventilator (HRV) or energy recovery ventilator (ERV), is a device designed to transfer heat energy from one airstream to another within a confined space. An air-to-air heat exchanger, as the air passes through the heat exchanger core, heat from the warmer airstream is transferred to the cooler airstream. By recovering heat energy from the exhaust air, air-to-air heat exchangers reduce the load on heating and cooling systems, leading to lower energy bills. Air-to-air heat exchanger are mostly used in commercial buildings, residential buildings, and HVAC systems. Regenerative heat exchanger. A regenerative heat exchanger is a device designed to recover waste heat from exhaust gases or process streams and utilize it to preheat incoming fluid streams. thereby minimizing energy consumption and maximizing thermal efficiency. In regenerative heat exchanger, fluid flows through a matrix that stores heat during one phase of the cycle and releases it during another, promoting energy recovery. Regenerative heat exchange are commonly used for gas-to-gas and gas-to-liquid applications. Regenerative heat exchangers are found in power plants, chemical processes, and metallurgical industries. Dynamic scraped surface heat exchanger. A dynamic scraped surface heat exchanger includes a rotating scraper to prevent fouling on the heat transfer surface, making it ideal for processing highly viscous or sticky materials. Dynamic scraped surface heat exchanger are used in food processing for chocolate and sauces, and petrochemical industry for handling heavy oils and polymers. Dynamic scraped surface heat exchanger prevents fouling and maintains high thermal efficiency. These heat exchangers are suitable for processing viscous and difficult to handle materials. Economizer. An economizer is a mechanical device or heat exchanger that captures waste heat from a system or process and utilizes it to preheat fluids, typically air or water, entering the system. By recovering and recycling this waste heat, economizers significantly enhance energy efficiency and reduce fuel consumption. By recovering and recycling this waste heat, economizers significantly enhance energy efficiency and reduce fuel consumption. By recovering waste heat, economizers reduce fuel consumption and operating costs of boiler. Economizer is commonly used in power plants, industrial boilers, and cogeneration systems. Kettle reboiler. A kettle reboiler, also known as a shell and tube reboiler, is a type of heat exchanger used in distillation processes to vaporize a liquid feed by transferring heat from a heating medium, typically steam or hot oil. Kettle reboiler allows for precise control of the reboiling process, suitable for various distillation applications. Kettle reboiler is commonly used in refineries for crude oil distillation. Thank you for watching. If you enjoyed the content,